Okay, we're streaming. Go ahead, Dean.
Hi there, Anthony here at Gigaparts, wanting to tell you all about the amazing radios that we offer here at Gigaparts, offering power supplies and other accessories. Gigaparts also carries refurbished computers from names that you know and trust, such as Dell, Lenovo, and HP. They make excellent ham shack PCs. We carry 3D printers, Filament. We also have amazing zero PCs. PCs with zero bloatware, zero compromises, and zero worries. If you're curious what else we stock, be sure to visit us at gigaparts.com.
All right. Good luck with the webinar.
All right. Welcome everyone to the 3D printing for ham radio or for amateur radio webinar. Your panelist for this webinar is Joe Eisenberg. I'm going to let him introduce himself. I do have a few notes though. Please use the Q&A function of Zoom to post questions. They will be answered at the end of the presentation, just in the interest of time. This webinar is also being live streamed on YouTube, and you can find information about how to access those videos at www.hamcation.com. Also, just so you know, your camera does not need to be on and your microphone has been automatically muted. If there is a special need, we may allow you to turn on your microphone temporarily, just put your hand up, but most of the questions should just be handled through the Q&A feature. Also, to be aware, there's a strict time limit for this webinar. We will stop the webinar at around maybe a little bit after 50 minutes after the hour, just to make sure that we have time for the next webinar. So without anything else, go ahead and take it away, Joe.
All right. I'm Joe, K0NEB, and I'm in Lincoln, Nebraska. And I am the kit building editor for CQ magazine. I've been doing that for almost 12 years. I'm in my 12th year of writing for CQ. And I'm also a contributing author to the ARRL handbook. I do the construction techniques chapter since the 2014 edition, in addition to traveling all over the place and putting on group kit builds and seminars and so forth. I love to get people building things. And one of the things that have come into kit building and so forth that I noticed was that sometimes the cases are either made from the printed circuit board material or now lately from a 3D printer. And I thought, boy, it would be nice to have one of those. So let me get started here and we'll get that up and we will, let's see here. There we go. And there we go. So we're going to start off by saying, what is a 3D printer? And I actually have it running next to me as we speak. This printer's running. You can see the table's nice, neat, and not cluttered in that shot. It is not so nice and neat right now because I do a lot of projects with this thing. This is a simple 3D printer. This is what they like to call an entry-level printer. This is an Ender 3 Pro, and they have a newer version of this out now. But it's a very common printer. It was pretty low cost. I think it cost like $220 or something when I bought it. And I've used the heck out of this thing. And I've made lots of things with it. Now, if you look at the top, you're going to see a spool at the top. That is the filament. And it's like wire, but it's made out of plastic. And it feeds through a driving kind of module. It's part of the extruder system. And what it does is it pulls the filament back or pushes it forward, and it goes in through this tube, this white tube, into this area called the extruder, which is kind of like a print head in an inkjet printer. In fact, I work on printers for a living. And so when I got a 3D printer, I thought, okay, nobody fixes these things. So you got to know what you're doing if you have one. So you got to be ready to fix it yourself. with most of these 3D printers. So since I was used to doing it, I looked up online, and although the manufacturer doesn't have a lot of support, there's a zillion YouTube videos on how to do all the different things to do all the maintenance on this printer. And what you're looking at is a printer that was run 24/7 for 3 months. And I've kept it up. And I've had to replace almost every part in it. But let's take a look here. You can see the controller here on the right. It's an Arduino-based thing. And actually, the controller itself is in this box here on the left. And the table that the object that you're making sits on has a special magnetic mat on it. And it's a textured plastic mat. And it is heated so that the object doesn't warp. Because of the temperature difference, and it moves back and forth. It moves forward and back, and then the head moves left and right, and then the gantry, which is that thing that holds the left-right motor, moves up as it goes layer by layer. And that's how a 3D printer works. So if you think of an inkjet printer like you have at home that you type your letters on or print your manuals or so forth on, it's just like that, except that when it's done printing one layer, it moves up, like in this case, 0.2 millimeters, and starts all over and prints again. So let's take a close-up look. This is the extruder. This is like the print head. And you can see there's 2 fans on it because it gets really hot, but we want to regulate the temperature of this thing. And we want to cool down the object where we just sprayed or laid down hot melted plastic so that it doesn't warp and it goes on nice and neat. So you can see this little thing down here, this little silvery looking thing, and it's got a little plastic sticking out of that. And I did that on purpose. I shoved some through so you can see what comes out. And it just basically squirts it in a pattern that it follows. And that pattern is created by your slicer program. We'll get into that in a little bit. As you can see, there's a knob here and a spring and a screw, and there are 4 of those on this one. And adjusting those is how we level the bed so that it actually meets the print head at the same height all the way through, so we don't have any problem with plastic not laying down on the bed and going on straight. So let's take a look here. This is where I was making a call sign, and I like to make these for friends and so forth. It does take a few hours for it to print it, but it does a really good job. And if you'll notice inside this print, you'll notice it's not solid. There's kind of a matrix in there. And the reason for that is that if you make it solid, if it's over a certain thickness, it's going to warp. And you don't want that. It also wastes a lot of plastic. So if you're making call letters, it's okay if the thing is hollow. So what it does is this is 20% infill. So you have like about a 1 millimeter thick outer coating, and then you have this infill. And you can see it's in a pattern, and that pattern is determined by your slicer program. All right. What do we use to print? Okay. These are the 4 or 3 kinds actually of materials that we most often use for filament. And like I said, the filament is that spool full of plastic, and it comes usually in 1 or 2 kilogram quantities. There's smaller ones as well, but the most common are 1 and 2 kilograms. PLA is by far the most commonly used plastic that we use because it has, it's low cost, has a low melting point, good strength, and it's actually non-petroleum based. It's actually vegetable based, and it makes pretty nice little things. In fact, about everything I'm going to show you was made with PLA. PETG is a lot stronger, but it requires a higher head temperature to melt it enough to lay it down. I would use PETG if I was putting something outdoors. ABS is probably the most expensive and the strongest, but you have to turn the heat up way high, and it can be fussy. It can be kind of messy. You might get a lot of strands and other things that you don't like when you print. So ABS is kind of the most fussy type of material. You can get it in just about any color. In fact, I get it in glow in the dark. Some of these call signs I've made for people actually glow in the dark. So they've told me, oh, I set it on top of my radio, but when I turned off the light, it glows green. Well, yes, it does. You can get the stuff in virtually any color of the rainbow, and there's even silvery and gold colored ones, and there's wood grain infused ones. There are semi-metallic filaments that work. There's just all sorts of different filaments out there. So you don't have to use just white or blue or green or purple or whatever. In fact, they have some filaments that change colors as you go, which is kind of interesting as well. And by the way, the filaments I buy sell for anywhere from about $16 to about $30 a spool. So why do we use 3D printing? Well, number one is to make prototypes. You want to, make something, you're looking at making a case for a kit or something like that. Here's your way to do it without having to cut wood or metal or things like that. You can make a prototype of something. So it's a great tool to be used with a CAD program. You can also make things that are not normally available or things that you need urgently. There was a darn simple sensor flag, which was just a 1 inch by 3/8 of an inch flag that had a hole in it, and it went into a thermal printer for work several months ago, and I couldn't order one of those things. The manufacturer doesn't make those, so I went home and I made one on the 3D printer in about 30 minutes and went back to the customer site, put that in, and now the printer knows when the head is closed and it works. In fact, after I had a successful run of that, I made about 10 more, put them in an envelope and keep them in my tool bag because those parts seem to get brittle. So you can make parts for things that don't exist anymore. You can make replacement knobs or a bigger knob or something for things like a KX2 or KX3. There's all sorts of things available. And if somebody's designed it, chances are they've put it online. And there's a website called Thingiverse that you can download them, and there's several others as well. And most of these things are free for you to download, and you can put it into a CAD program and modify it yourself, and then re-upload it and say, hey, I enhanced its design by making it work on this. And so a lot of things are public domain and available on the web that you can download and make. And of course, you can make this stuff at home. It's not real fast. To make one of these call sign things is anywhere from 4 to 6 hours. To make certain kit cases, it can take 2, 3, 4 hours to make each different part. But once again, I've made it myself, and if I want to modify it, I can take that design and say, oh, I'm going to add another hole here, and now I can put an LED in it and things like that. The disadvantage, if you're talking about mass production, is it's more expensive per item and a lot slower process than injection molding. But in small quantities, it's a lot cheaper actually, because you're not making a mold. All you're doing is printing it. And a lot of the customers I have that are manufacturing plants have both small and very large scale 3D printers that they use for making their prototypes, or even to make the object that they use to make their mold. All right. So let's kind of go through the process. You can download a design or create it using CAD software. There's a lot of free programs available, and a lot of things mostly are on Thingiverse. And you can change them, like it might be a name plaque with your call letters or whatever, and you can take it and change what name is on the original design, things like that. And then once you have the finished object that you think is what you want to print, you take that file. It's most commonly what we call an STL file. And by the way, there are several kit sites like qrpguys.com that have the STL files already made for you for some of the kits. And I'll show you one of those in a little bit. And you can download that and then use a slicer program. The slicer program is more peculiar to your printer. Now there are several ones, several of them that are out there that a lot of times come with the printer. The one that I use is called Cura, C-U-R-A, and it's a free download, and it has settings for most of the common 3D printers in use today. So I just tell it which printer I have, and it says, oh, now I know how to make a G-code file for it. And then you put the object in there, and you can resize the object again if it's not quite right, and you just need to shrink it or stretch it one way or another. And you can adjust it. You can adjust its position on the print table so that you can make more than one. You can make 2, 3, 4 at a time. It just takes longer to do it, but sometimes your design might work better if it's flat on its back, or if it's upside down or on its side, for it to print without using what we call supports. So that's what you work with the slicer program. And that makes the final file that the printer uses. In my particular case, my printer uses a G-code file. Don't take a G-coded file from another printer and put it on yours. You really need to slice it with the program that's set up for your printer. What I do on my particular printer, I have two choices. I can either have a USB cable with a driver running from the computer that prints to it, but then that ties up the computer all day long, and you don't want to turn the computer off. What I can do is, with this particular printer, I also have the option of saving it to a micro SD card. And then what I do is I put that micro SD card in, and through the menus on the Arduino controller, I can find that file and execute it and have the printer run it. So once you've got the file in there, the first thing I do is I home the head, and we call that auto homing, and then I shut off the steppers. And what that does is it makes it loose so I can move things around a bit. And I put a sheet of paper in there, and that's pretty much the way a lot of people level their boards. There are auto leveling printers, and I suggest if you're going to do a lot of 3D printing that you get one that has auto leveling so you don't have to do all this. In my case, I put a piece of paper there, and I move the table and the head back and forth, front and back, left and right, and I make sure that all four corners are about the same amount of friction and so on. So we know that that bed is level. Then I rehome the head again, and then I preheat it so that it's all ready to accept the plastic, because if you don't preheat it, that bed's going to be cold and it may not stick to it. So I do the preheat function, which lets me preheat the head so that it melts the plastic and gets it flowing, as well as getting that bed heated up. Then I execute the print file and I monitor the print, and we'll show you one that's in progress right now. Once it's done, I let it cool down pretty thoroughly, because if you try to pick it up too soon, it may be warm enough that it might warp when you try to pull it from that level bed. So what I do is I make sure that the extruder and the bed both are showing close to room temperature, which might be like 26 Celsius or so. This is what it looks like when you're using a CAD program. And this particular CAD program is a website, and it's absolutely free to use. And this particular one lets you can make the call sign things. I've made kit boxes and all sorts of little gadgets and knobs, and you can pretty well make anything you want, and then you can store it online, which is really cool. I think I use my Facebook login, and it keeps it in a area on the cloud so that I can come back anytime and I can pull up my previous designs and modify them and so forth. But this one, and I can't remember the name of this site, but I will, if somebody asks afterwards, I can quickly look at it and look at my browser and see what it is. But you can see it's got a grid that's precisely marked, and you can adjust things to within 1/100th of an inch. It's really amazing. And I've made a lot of stuff using this free website, and then it saves it to your computer when you're done. It downloads it, and then you use the slicer, and then you print it. This is Cura, and so this takes the design that's already done, and then I can move it back and forth, left and right, position it the way I want it to be on the print surface before I make it. And this one was one I made for John Knott, who is on the committee and is the president of the Orlando Club. And so it has different functions on this as well. It lets you adjust its position. You can adjust its size, all sorts of things. You can make multiples. So I can take one design and I can, especially if it's a small object, and scatter it throughout the board, or line them up, and then make multiple items at the same time. So what kind of things can you make for ham radio? Like I said, kit cases, plastic replacement parts. A lot of these little plastic parts sometimes are made of what we call unobtainium. Well, if you can find it, sometimes somebody else has had the same problem and they made it. So you can look on Thingiverse and see if you can find it, or take measurements and see if you can make it yourself with the CAD program. Dipole insulators. I've made a bunch of 6-meter dipoles for people, and they work wonderful. They're designed to be taken out on field day, and it just uses a panel mount SO239 and some wire and a piece of coax, and away you go. It's got the end insulators and everything. There's a lot of recipes out there for making a Morse code key or paddles. There are a zillion stands that hold your HTs, especially the guys that are on DMR and also that use the small QRP kits, like the QCX series and the FT817, 818, and the KX2 and the KX3. There's a lot of desk stands for those that tilt it up and make it a lot easier to work with. There are mic holders and mic stands. 3D call signs is one of the things I love to give to my friends. The one I'm making now is for one of the guys that was on my roof and on my tower in November, and it is on the front page, front cover of January CQ magazine. He is up on my tower, so I'm making him a call sign for his shack. He's a new ham, and been very helpful with climbing some towers lately. And so I thought I'd make him something for all the effort he put in, along with the rest of the tower crew are getting them as well. You can make antenna parts like supports inside a trap and things like that, and RF chokes and things to wind up backpack antennas and so forth. You can make with this coax guides and so forth, like a tube to go through the wall and so forth. You can all make with a 3D printer. So here's some of the fun stuff you can make. This is a QRP Guys kit. It's a double sideband digital mode transceiver, and I've used that on FT8. And you can see it's got holes for the receive and transmit lights. Now the lettering I'd made with a brother label maker, and it's kind of in 2 pieces. And the board just lays in there, and you slap the lid on it and screw it shut. And you can see what one of the call signs looks like there on the right. This is something not radio related, but I made this for my son. This is a 3D dice tower. And on the right is what it looks like, all collapsed down. It stores away like that. So when he's playing games that use multi-sided or multiple dice, he has a way of rolling it without them going all over the table, because what you do is you pop off the lid, and that becomes the receiver part of it. And then you pull up the crown of the castle, and then you turn it about a quarter of a turn to the right, and it locks it, and then you push down, it locks and holds it. And that top part of the castle actually has a hole in it that you can't see. And you just drop the dice in there, and it's kind of like a funnel, and it drops them through different ramps and barriers that make the dice tumble, and they come out a chute at the bottom and slide out into the receiver area. And it's kind of neat. And then to put it back for storage, all you do is you pull up on the lid, and everything comes straight up, and you turn it about a quarter of a turn or so counterclockwise, and then push it down, and it all collapses down like you see on the right. Now, this took about 3 days of different printing sessions, and then a lot of work trying to cut off all what we call the supports to make that stuff mold correctly. But the end result is something that's very nice looking. So you can make a lot of neat little gift items. This is a 3D printed face shield. At the beginning of the pandemic, our first responders here in Nebraska had no source of face shields. They'd never really needed this kind of thing before for transporting patients. And so the university started making them, but they wanted too much money. I said, well, I'll make you some. I ended up making over 300 of these, and I donated everything, the material, the extra foam padding for the forehead thing. And I ordered the elastic online, and the 2 items I 3D, and I ordered the plastic face shield that snapped onto this. The design was a National Institutes of Health design. And that's the one I used instead of the ones that look like cheap hair bands, because this gave the most protection. And I gave a sample to one of the firefighters, and he said, please, how many of those can you make? And I started making them. And because my design was much stronger, it took a lot longer to print and assemble these things. So I could make maybe 7 or 8, 6 to 8 a day. And the 2 plastic pieces I made were the tie thing that goes behind your head, that's you can see kind of at the bottom of the picture, and that is where the elastic goes, and the big white plastic front piece that holds the plastic face shield. Now, when you look at the cost of it, I think it cost me, once I divided out all the filament cost and the parts cost to maintain the printer and so forth, because an entry-level printer is not really designed to be run 24/7. And so I learned all about rebuilding printers, and I ended up using much higher quality parts that you could buy online from third-party vendors that actually last a lot longer, and then you don't have to repair it as often. But these, I got the foam from Menards. It is the same stuff that you use to insulate when you put in a window air conditioner, and it's got adhesive on it, but I also put crazy glue on the visor, and it holds it real nice and tight. The plastic sheeting can be removed and replaced. So they were able to order the plastic sheets that I used, and keep reusing these things as long as they wanted to. But I supplied over 300 of these to Lincoln Fire and Rescue. Things that I learned about this project, because I had only used the printer to make a couple of call signs and a couple of kit cases and some knobs and some other small ham radio things before I suddenly found myself making the printer run round the clock. Entry-level 3D printers are not meant to be run 24/7 for 3 months, but they can if you maintain it. So you keep the area, the printing bed and the printer clean. You got to order extras of those mats because they do wear out. Keep it clean, especially on the rails and pulleys, because there's little pieces of plastic that come off and stuff, and dust and dirt that get in there, and that can slow it down and make it not move exactly smoothly. So you want to make sure that's kept very, very clean. Brass nozzles are what are supplied with the printer. They're very cheap. I've seen them like less than $1 a piece, like 10 for $5 and stuff online, but they don't last real long and they're not as precise. I got stainless steel ones and they were about $20 for one print head, but I could run that same print head for weeks, 24/7. I think they lasted me like 3 or 4 weeks, while a brass nozzle might only last me 5 or 6 days running it 24/7 before the tips of it wore out. Keep spare parts handy. You can get different kits like heated bed and the controller board and the extruder, that what we call the hot end. Um, there's new cables, the Bowden tube, which is the white tube that feeds from the extruder drive into the extruder. There's extruder drive gear kits and stuff because they do wear out. That plastic is a little bit abrasive, and so when it goes through, it can wear down the original plastic extruder drive. I got the metal one. YouTube is absolutely your friend. There's a lot of people who've done this before you if you're using a common printer like this Ender. And so there's a lot of people out there that have had different problems, and they can help you solve it just by watching their YouTubes. So buy one that's pretty popular. So you have a lot of sources of online support, user groups, and learn how to use your CAD and slicer programs, because that's key to making your objects correctly. This is another thing I made at the beginning of the pandemic. These are ear guards, and these are for your people that have to wear a mask all day long. And they're still popular. In fact, I still make them from time to time and keep a few in my car, because a lot of people complain about the strain of their ears having the elastic on it. And this lets you hook the elastic to the binder and put that behind your head so it doesn't deal with your ears at all, and you can adjust the tension. So this is another thing that you can download on Thingiverse. And this is that kit case that I showed you earlier. And we're going to, let's see here. I'll bet you see me now. Hopefully that worked. And like I said, this is the kit case. It's 2 pieces of plastic, and not bad at all. Works real well. The call signs, this one is solid white. This was the first one I ever did. And it's a little thick, so the newer ones I make are a little thinner than this. But once again, these things are hollow on the inside. They don't need to be solid. They're quite strong. This is one made with glow-in-the-dark filament, but I'm not going to turn off the lights and let you watch that thing glow in the dark. Right now, the 3D printer is running. So what we're going to do, this is live television, folks. You're going to see, there we go. You can see the 3D printer is operating. It's tracing out those lines, and it's making that matrix inside so that you don't have to use up all the filament to make these call letters. Because if you made it 100%, this would take about 15 hours to print, and it may warp when it's done. And it's just as strong when it's done like this. So if you think of it kind of like a bridge that has girders on it, well, those are kind of like the girders inside the bridge. Now we can take a look a little closer. I don't know how good this is going to be, but now you can see it's just putting down the lines of plastic on there. This is the controller, and I don't know how well that's going to work. It's showing that we're running at 220 degrees Celsius, and the bed is at 60 degrees, and it's showing you the constant X, Y, and Z position of the print head and how much time we have in the print job. So it doesn't show up real well, but there we go. And that's how a 3D printer works. And This one isn't as noisy as some, but the newer ones come in, you can get them, they're a little more expensive, come in cabinets that let you enclose it so it doesn't make as much noise. This is the Extruder Drive, and you can see that thing. And it's moving the filament in and out. The white stuff that you see on there, I just recently lubed the Z-axis, which is the threaded drive at the top. And the threaded drive, what it does is it raises and lowers the gantry, which is the vertical part of the 3D printer. And sometimes, especially now when it's very dry inside, my indoor humidity right now is 22% because it's below zero outside. And so it gets a little sticky. So I use this kind of a dry lube that I spray on it. So it kind of makes a little bit of a mess until I clean that off. But you want to have all your axes moving smoothly so you don't get any jitters or any irregular lines on it. And that's how I end up with something really smooth like this that looks just absolutely smooth, and you don't see any extra lines or anything. It's just nice and smooth and no little extra strands and stringiness and so forth. I am ready for the questions.
All right. I will read them out to you. That'll probably make it a little easier. So first we have, do you have a recommendation for a printer that doesn't need all the parts replaced? I've already gone through that stage with a $240 printer, and I'm ready to pay more for a lot less hassle. Thanks.
Yeah, there's several that are more heavily made. This particular one, like I said, I've even replaced the belts and the bushings and all sorts of things, the pulleys, and I've done some modifications to it that improve it. I can't recommend a particular one, but I know that there are several in the $1,500 to $2,000 range that come in a cabinet and so forth. And most of those are built for educational institutions and so forth. And if you're going to use one quite a bit, that's what I would use, because those are much less likely to need more maintenance than an entry level. However, like I said, by using much higher quality parts than the OEM, I've been able to, at a lower cost, improve this one.
And we did have a suggestion from one of the attendees for Prusa printers, which I'm going to paste the link to that in the chat.
Yeah, Prusa is an interesting printer because most of the components in a Prusa printer are actually made on, you're going to love this, a Prusa printer. In fact, what you have is a 3D printer kit where most all of the plastic parts are made by Prusa on another Prusa 3D printer. It's very fascinating. And the Prusa printers are extremely popular. They are a kit, and being a kit builder, I highly endorse doing that. Just make sure you follow all their directions carefully about the way you assemble it so the bed goes in level and things like that. But the Prusa printers are actually made with parts made on Prusa printers, which is absolutely fascinating. And they are excellent. I know that there's auto level modification kits to this printer, things like that. I just haven't done it. I pretty much manually do that still.
I also, so the next one is not really a question, but more of just a statement of, don't forget to mention that ABS needs to be vented while it's printing.
Yeah, that's because when you heat ABS up, it releases certain vapors, and so that is a problem with the PLA. You don't smell it at all. ABS does have that issue, but PETG and PLA do not. The other thing is, if you have a resin printer, and that's kind of a different animal altogether, the resin printers do have an odor problem where it needs to be in a very well ventilated area. So do not get what we call a resin printer unless you have a very well ventilated area. There are just a zillion printers. I'm trying to think of some of the lower cost ones that make smaller objects. I prefer to have at least an 8 or 9 inch square print bed. But I think there's a mono price unit that's under $100, and you can make knobs and small kit cases and stuff on it, and it works quite well. Um, the more expensive ones obviously are going to go faster than this one does as well. Now I could run this thing at a faster speed, but I prefer the higher quality of the finished product.
I wanted to remind the attendees, if you'd like to make suggestions of different printers and other comments on what we're saying to the rest of the attendees, make sure you select in the to box above typing your message, select panelists and attendees. So that way the other attendees can see your suggestions, because we do have other people posting their printer suggestions in the chat. Okay, so the next question is, what type of filament has the highest dielectric withstanding capability?
I don't know. I've never really looked into that, but I would guess that it would be the ABS or the PETG. But somebody also asked about odors, and you don't really smell anything from the PLA type, but you do if you're using some of the other types of filaments. And like I said, the resin printers, I would not put that in the living room. I'd put one of those in your garage or something. But
just make sure your AC intake or something isn't in your garage.
yeah, exactly. And I know somebody was asking about slicers earlier, and I really like Cura, C-U-R-A. Cura, it's freeware, and it's pretty universal. It's probably the most common slicer out there and one of the easiest to use. And they're constantly adding more and more printers that they support. Cura, C-U-R-A, is the one that I recommend.
All right, so the next question is filament material available as clear plastic?
Yes, there is clear filament now. The only problem that you have with that is you can still get some discoloration sometimes through the heating process, but there is clear filament. There's natural filament. There's all sorts of different filaments out there now.
I would say to keep in mind that when you are 3D printing, you're producing layers, so you end up with kind of a rough finish. So even if it is a clear filament, it could end up looking like it's a textured surface instead of a nice glossy surface. So just keep that in mind.
Yeah, and so that's the drawback on that. There are ways to make the printer slow down for the top and bottom layers and so forth. But I would have to look. That's kind of a more advanced thing. And I see somebody was asking me about Satnogs. Now that is the Azel rotator thing. That's kind of a homebrew thing that people are making with 3D printers. And when you're dealing with rotators, you have to work with probably the strongest plastic out there so that your gears, if it meets some kind of resistance, it's going to power through, unless obviously something is stuck. And I would probably suggest using the PETG or ABS if you're making a rotator. However, the ABS actually is not good in high temperature or low temperature environments. But if it's something you're taking out temporarily, like a tripod for field day and doing satellite work, ABS would be fine. But otherwise, I would use the PETG.
All right. Well, you already answered what slicer you use, and that's Cura. But what are the pros and cons of that slicer versus others?
I've used some of the others. It just seems simpler and easier to deal with to me, and it's the one that covers the most different printers on the market.
And you just talked about the ironing technique for the top layer, right?
Well, only a little.
Okay.
There's different in your slicers. Some of them support that, but I've never really had to use it because if you look at these, it's not perfect, but you can feel a little texture of the lines in it. But there's different techniques. Now, what some people do is they make that top layer extra thick. Instead of, let's say, 1 millimeter, they might make it a 1.2 millimeters, and then they use a belt sander, and they sand that with a real fine grit, and they can polish it that way as well. Okay.
I'm sorry, go ahead.
And there's a lot of things that you can use the 3D printer for. I know somebody here in town that makes objects for his model railroad display, and he's made signal lights and stuff, and he puts LEDs on it, and he makes the plastic pieces with the 3D printer. And it doesn't take that long to make some of these things. And he's made all the way up to different little houses and objects and stuff with it. And it's pretty amazing what they do. You can, there's some printers that allow you to have 2, 3, or even 4 different colored filaments, and then it will switch filaments for you to have different colors on the same object. I don't have that on this because this is a pretty simple one.
So we had some more questions about one person is asking, what printer would you purchase today? And another one's asking, what 3D printer should I start off with? Well,
the Ender 3 is still made, actually, and it's pretty good. There's a newer one, the CR6, but I have not heard a lot about that yet. The CR10, the Ender CR10, is probably one of the most common ones, and it has a lot of parts in common with the Ender 3. A CR10 series Ender works. A lot of the Prusa printers, I would say, are well worth it. Depends on how much you want to assemble. If you want to spend some time assembling it, like I do, being a kit builder, the Prusa is an interesting experience. The newer Ender ones have a lot fewer parts that you have to assemble now.
Yeah, and just actually personally, I just bought an Ender 3, and
okay.
And they a lot of the upgraded parts that you could buy for them aftermarket are now installed by default on the ones that come out of the factory. So
yeah, the new the ball bearing things and the stronger belts and the belt tensioners that you just turn the knob, that's all part of it, isn't it?
I had to print out belt tensioners. I
Okay.
used Petg for that, just for the strength of it. But yeah, everything else was already installed.
Yeah.
So we had a question. What experience have you had with resin printers?
I have not. I have seen one work. There was, before the pandemic, I would go about every other week. There was a 3D printing group here in town, and they had one of those. And of course, that was kept off in the other room in the garage because of the smell. But the products that it makes were incredible. Of course, the thing that you would almost see most often was baby Yodas, which I think you've noticed already. About everything you can possibly make, you can make a baby Yoda out of it. And things like that are much smoother with a resin printer than it would be with the regular layer type.
Yeah, and I hope you don't mind if I butt in here. I do. I actually have a resin printer. I'm like co-owning it with one of my friends, and it is a much steeper. It's not a steeper learning curve, but the cleanup for it is messy, and the smell, and just basically, if you're interested in 3D printing, start with one of these and not with a resin printer.
Yeah, but the object that you get is superior with the resin. But to me, it wasn't worth the hassle to go into the resin. So that's why I stuck with this.
Yeah. So can you bridge the plastic over a hollow space, such as in making the letters hollow to save material and weight? What are the restrictions?
Okay, well, in what I'm printing right now, it's kind of semi-hollow inside. There's problems with what we call bridge things within objects, some of the kit cases and stuff, and like that dice tower had bridges in it. And the problem is that as that goes, it it sometimes would fall because it's still warm when it gets another layer. And what they do is there's a way to create what's called supports. And what that is it's just lines that go down. And so it makes like a cage. So it almost looks like a jail cell or something. And what it does is it supports it when you're done printing the object and it cools down and you take it off. Then you take an X-Acto knife, and it has kind of a thin attachment to the object being supported. And you cut that plastic off and you just throw that away. And that's how I was able to make something so beautiful as that dice tower, was by using supports. And so that's something that you'll see in your slicer. Do you need supports? You can tell it not to use them if your experience has been that object doesn't need them. If the object has just vertical and horizontal and does not have any bridges, then you would never need supports. But if it has something like an archway or something, then you would build it with supports and then remove them when it's done.
We had another question about showing the websites for longer, and I just wanted to say that this presentation is being recorded on YouTube, and you'll be able to go back and look at it later. But is there an email address or that they could contact you at if they have more questions, and or are you going to be sharing your presentation like file with the audience?
If somebody actually needs it, they can email me, and it's easy. It's Joe, J-O-E, at K0NEB.com. Joe at K0NEB.com. And the neat thing about 3D printing is it kind of marries well with Arduino and Raspberry Pi. There's a lot of these that use Pis as their basis. Some of them use the Arduinos. And it's just amazing to watch it work. And it works on its own. Like I said, I chose not to have it connected to the computer. That way, if I mess something up on the computer, I'm not going to disrupt the print job.
Yeah, and we did have some talk in the chat about Octoprint and Octopi using a Raspberry Pi as the USB host for the file. I don't know if you have any experience with that.
The Octopi?
Yeah.
I have not.
Okay.
I don't know anything about that.
So that is basically software you load on a Raspberry Pi. You can it lets you network your 3D printer, and you can also hook up a webcam so that you can remotely monitor and even remotely control the 3D printer with virtual jog dials and things like that.
Oh, that's interesting. I'll have to look into that because I've got a Pi 3 sitting underneath it that I use for different things, and that might be a way to go, so I can webcam it and watch it while I'm away. That would be kind of nice. I kind of like that idea. That's the neat thing about 3D printing is there's just so many things you can do with it. A lot of people say, why would you have it? I think the firefighters here are real glad that I had it. I produced them for almost 3 months until they finally got a supply from the state. And the state gave me that certificate that you see underneath the Zulu clock for that.
Yeah.
They made me an admiral in the Nebraska Navy. Now think about that. But that came from our governor.
Yeah. So we have a couple more suggestions for 3D printers. Somebody mentioned See Me CNC. So that's I'll post the link in the chat. And then another person mentioned Lulzbot. Lulzbot.
I've seen those.
Yeah, they're saying they've run it for 3,495 hours without any repairs.
Well, yeah, definitely. You get what you pay for when you're talking about 3D printers. And there's almost no support from Creality itself for these things. But my friend who has a Prusa, he told me that he can email them and he gets responses right away that are very good. So Prusa is pretty good about support. Like I said, it's a kit, and I love kit building, and that might be one that I might make in the future.
Yeah. And we're about out of time now. So do you have any closing remarks?
Other than keep building kits and enjoy 3D printing, because this is a technology that fits well with amateur radio, and it lets us enjoy the hobby even more by making things ourselves and enjoy making things. That's what I like doing. That's why I build kits and have a 3D printer.
All right. Well, thank you so much for everybody for attending this session. Contrary to what I said earlier, this is the last session of the day. Sessions will resume tomorrow morning. Again, this will be available on YouTube. I did get some questions about where those links will be and where the videos will be. And if you just go to hamcation.com, you'll find the links there. The videos might not be populated for a few hours or maybe even a day as YouTube crunches through the video and creates the hosted version of it.
Yeah, I saw a host message that we can run longer if we'd like. So if anybody else has questions, we can rock and roll.
Okay, well, I'll keep going because there were some left over. I'll go ahead and stop the